All right. Up until now, I've been showing you guys how we got the formulas, yes? And we discovered that every shape we've dealt with so far is simply shapes from kindergarten folded together to make something different, yeah? A pyramid, square on the bottom, 4 triangles, right? A cone, circle on the bottom, then a section of a circle. A rectangular prism, a rectangle stacked on top of itself. Everybody's good? Okay. Spheres are different because they expand in every direction. So you can't draw a flat version of a sphere like you can a pyramid or a cone or anything like that. Okay? So the formulas were derived through experimentation. Everybody with me? What I mean by that is if you take a ball and you put it in water, it makes the water go up, so then you know the volume, and then they would do algebra backwards to figure out the formulas. You don't need to know why, you just need to know how to use them. So let's start with this very first one. Is there anything about either of those formulas that you don't already know? Do you know what an R is? Radius. Do you know what a D is? Diameter. So you already know how to use this formula, yes? If it's a sphere. What's a sphere? A ball, right? It's an infinite array of circles, yes? They've all been spun around and they make the ball. Everybody cool? Okay. Everybody has no problem with spheres. The formula's right there. You know how to use it. It's easy peasy. When you start getting into trouble is when we have hemispheres. What's a hemisphere? Half of a sphere, yes? Right? Everyone agree? Okay. So logically, if the surface area of a sphere is 4 pi r squared, what is the surface area of a hemisphere? What would you do to that surface area? You would divide it by 2, correct? Agreed? Everyone understand? And you would get 2 pi r squared. Is everyone cool with that? This is why it causes problems. Observe. Don't write this down. Just watch. Pretend that's a ball because it's impossible to draw a ball. Yes? Pretend it's a solid ball, which means if I dip it in paint, it will all be covered, yes? And that surface that I dipped in paint is the surface area. Agreed? And that surface area of a sphere would be 4 pi r squared, yes? Now, this is a solid sphere. I'm going to cut it in half. So what is that? Is that solid or is it empty space? It's solid because I told you it was a solid sphere, yes? Which means if I dip that in paint, will paint cover that circle? Which means what is happening? Is that increasing my surface area or decreasing it?
There is still surface area there, but it probably used to be there.
Let's talk about what I mean. On the original sphere, if I dipped it in paint, all of this would have been green, yes? And all of that would have been the 4 pi r squared. Everyone agree? So when I cut it in half, this green part would become 2 pi r squared, yes? Everyone agree? But as soon as I cut it in half, what did I make right here? A circle. What's the area of a circle? 1 pi r squared. So the green part is 2 pi r squared, which we all agree on, but I have to remember to add 1 pi r squared. What is 2 pi r squareds plus 1 pi r squared? 3 pi r squareds. So I have to remember that if I am doing a solid hemisphere, that I am actually adding that circle when I cut it in half. Is everybody with me? Everyone's cool? All right. Now, using your brain and not writing it down, because you don't need to write it down, what if this were a hollow hemisphere? A hollow sphere. So when I cut it in half, this is empty space in there. Now what's the surface area? Almost exactly the same as if it were a full sphere. Would it be exactly the same, do you think? You say no. Why?
Because there would be a little bit.
There would be a very little lip here, yes? For the thickness. But doesn't that lip count as surface area? So what would it be? Do you think it would be exactly the same? A little bit more? A little bit less?
I think it depends on how.
Close to the same? It would depend on the thickness of the lip, wouldn't it? Everybody with me? But it would be pretty close to the same. Everybody cool? All right. Let's go over to volume. I do not like writing volume that way. Why? Because the fraction stinks. I don't like fractions. So when I do volume of a sphere, I write it this way. 4 pi r cubed all over 3. Which means what math is happening right there? Division. So on your calculator, you would do the yellow stuff first, then you would divide by 3. Everybody cool? For a regular sphere, what if it was a hemisphere? A hemisphere is what? Half a sphere. So I would have 4 pi r cubed over 3 divided by 2, yeah? Because I want to cut it in half.
It wouldn't be as easy as just making it 2 pi r cubed.
No, it wouldn't be. Or is it?
Kinda yanking me back.
Where's your book? Oh, I do not have any. I have paper towel right there. I'll say it slower. I have paper towel right there. Stop the bleeding first. Paper towel right there beside my kettle. That's okay. You'll wipe it up when you're dealt with the bleeding.
Did he get a paper cut?
I don't know. I cannot read his mind. I also, in 17 years of teaching, have had blood in my class like twice, so I don't keep a lot of Band-Aids about. Are you all right?
Yeah.
Good man. Hold it above your heart. Yes. Squeeze it really tight. Hold it above your heart for like a minute, and it will stop bleeding. Now, Aiden, if I want to divide that by 2, that's the same as multiplying by a half, isn't it? So I get 4 pi r cubed over 6, right? What can I do with the 4 and the 6 there?
You could divide the 4 by the 6 and then times the remainder by
2 pi r cubed over 3. It is that easy. Okay? Everybody cool? All right, so now we're going to do only 2 questions because there's only 2 little things that are new. The first question we're going to do is a stupid math class question, right? It's not a real life question because if you read it, Amber's going to give her brother a basketball for a present and she's going to wrap it. She's going to wrap it as a ball, apparently. Not much of a surprise. Here. And it's a wrapped ball. Oh, what'd you get me? I don't know. It's a math class question. So let's solve it. So since it is wrapping paper, is it a surface area question or a volume question? Surface area. So I must be dealing with the surface area of a sphere, yes? Because a ball is a sphere. Surface area equals 4 pi r squared. Now, this is a weird question. It's the first one of these we've done. Normally, when we do a surface area question, we are trying to find the surface area, aren't we? But in this case, what is different? We're going backwards. We're going to do some algebra. And there's a reason I want you to do this, even though it's a stupid math class question. Because it's not important what the radius of the basketball is it? If you're going to wrap the basketball, it doesn't matter what the radius is. But there's a reason I'm doing this. So, in that question right there, what can you fill in right now?
You could take the 2,500 and divide it by 4.
Well, first you're going to fill it in. The 2,500 is the surface area, isn't it?
Yes.
So you're going to write 2,500 equals 4 pi r squared. And we're trying to find r. Now, we just did a quick reminder of how to do algebra. So let's go through it now. How do I get r by itself there?
You could square root both of them.
I can't square root right now, because if you square root right now, you've got to take the square root of pi in the middle of something. That's barfy.
Yeah, that's it.
So what should I do?
Divide by 4, just to get rid of it.
The question I should be asking is this. When you're doing algebra, you want to end up with r by itself, yes? Or x, or q, or p, or whatever. So when should you address the variable? If you want to end up at the variable, should you start at the variable? If I want to drive to Disneyland, do I start in Disneyland? No. I start far away from Disneyland and drive there, correct? So if I want to end up at r by itself, can I start doing anything to r at the beginning? No, I got to start as far away from r as possible. So Aiden says he wants to get rid of that 4. Now I gave you the reminder, when you do algebra, if you see math, what math do you do? The opposite of what you see. What math is happening with that 4? It is multiplying by pi and r, yes? What is the opposite of multiply? So if I divide both sides by 4, I'm going to get an answer. I'm going to get 625 equals pi r squared. Is everybody okay to there, algebraically speaking? Excellent. Now what's in the way of r being by itself? Pi. What math is happening to pi?
It's being multiplied.
You see multiply. So what math do you do? So now, can you do that in your head?
Probably not.
I can't. So where do you have to go to figure that out? You're going to go to your calculator. Now, why are you going to your calculator when I've said, hey guys, I want you to leave pi as an answer? Why are we going to our calculator here? Because the question is actually needing a number. Okay? So what are you going to do there? You're going to do that with your calculator, and what are you going to get?
198.9, etc., etc., etc.
0.9 equals r squared. Is r by itself yet?
No. Wait.
No. What's in the way of r being by itself? Squared. So I do the opposite of what I see. What is the opposite of squaring something?
Square root.
Square root something. And I get an answer of something like 14.1 equals r. Is everybody cool with that? It's a stupid math class question, I agree, but the algebra skills are useful. I want to do something else with this before we go on, though. That's why I left it way over on the left. Is everybody cool with that? Okay. Now, how many times did we have to go to our calculator here? If I hadn't written 2,500 divided by 4 is 625, wouldn't you have needed to go to your calculator there? Probably, right? Calculator there, calculator there, calculator there.
If you wanted to do it,
3 times, right?
you couldn't do the divided by pi in your head or the square root.
No. SA equals 4 pi r squared. All of you can do this algebra as soon as there's numbers. Over here is where you have problems because there's no numbers. When you get to physics, if you take physics, chem, if you take chem, you often need to move around equations without having numbers in them. And for some reason, that causes you guys problems, even though it's the exact same thing as what we did in red. If I gave you no numbers and I said, what's the radius? What would you do?
Have a panic attack?
You would have a panic attack. But it's the same thing, isn't it? When I say what's the radius, that means I got to get r by itself, yeah?
So would you...
So you do the exact same thing. I would divide by 4, and I would divide by pi, right? So my surface area would divide by 4 and pi. And that would equal r squared. Then what would I do? Square root the surface area divided by 4 pi would get r. Now, how often do I need to go to my calculator? Once. Every time you go to your calculator, is there a chance you push the wrong button? Will that button give you an answer on your calculator? Will you believe your calculator before you think about it? All of you nod your heads. And will you write down the wrong answer? Half of you nod your heads. And when I say, how could that possibly be the right answer? What will you say? My calculator said so. Right? If I asked you what 5 plus 2 was, and you went to your calculator, and you hit 5 times 2 by accident, and hit equals 10, you would all tell me that 5 plus 2 is 10. And I would say, why? Because my calculator said so. Everybody understand the problem?
Why does gravity pull things down? Does the apple drop?
It doesn't pull things down. Gravity pulls things to the center, not down.
And down.
There is no up and down. Gravity pulls things to the center of the mass. The other thing you should know, Aiden, is right now, between you and I, if the Earth wasn't here, if we were out in space, we would go like this. Because you have gravity and I have gravity, because we both have mass. I am fatter than you, so you would be attracted to me. It's a fun physics problem. I have a bag with $1 million in it. I'm floating in space. My spaceship is right over by Hannah. But my lifeline has been cut. How do I get back to the spaceship?
Wouldn't you put the $1 million in front of you to try and use its mass?
You couldn't. Because for every action, there's an equal and opposite reaction. The only way to get back to the ship is to throw away the $1 million. And then you get pushed back to the ship. Unless you're Princess Leia. And then you're okay in the vacuum of space. Sorry if I've ruined... That's a bit of a spoiler if you haven't seen Last Jedi yet. Huh?
Wasn't she like only out there for like...
No, she's dead in real life. All right. Turn the page over. This is the last question we're going to do. Then I'm going to shut up and let you guys work for the rest of the period so you have no homework for your long weekend. And it's a perfect day to do work because you have 1, 2, 3, 4 grown-ups in the room to help you with your math. Count them. 4. That's 1 more than 3. And 1 less than 5. I count Kelvin as a grown-up. Kelvin has been in class with me for 3 years in a row. That's like dog years, right? A year of math class with me is like 2.5 of math class with anyone else.
I'm done. Obviously, all this.
All right.
A diameter of 3 centimeters.
Let's read this question. Some of you will say, Myers, you tell us you don't give us stupid-ass math class questions. But this is not a math class question. I'll tell you why not, Ryan. Who decides how stuff gets packaged? Everyone? You decide how your shoes are packaged? You decide how your pasta is packaged? No. Who decides? The company. What does the company do? Just say at random? Just make some boxes. They have machines. Isn't a machine just a calculator? So how does the machine know how to make the package? Who had to tell it? A programmer. Who is a person. So this is not a stupid math class problem. Somebody makes these decisions. Why is it important? Is packaging free? No. Packaging isn't free. It costs money, yes? So if you package badly and you have to spend more money at the factory, what does that mean for you guys buying my product? It's going to cost more. Do you guys want stuff to cost more? No. So this type of problem is actually a real life situation. And somebody always says right there, not in my life it won't be. And then we have the big argument, well, you can obviously see the future, so tell me the lottery numbers for next Wednesday so we can all quit this job. You can't see the future. You have no idea if you're going to end up making a decision on whether or not you need to package golf balls in a certain way. Right? Right. So let's do the question. Why is this important? Because you don't want any extra space, do you? If there's extra space, that's extra materials. If there's extra materials, that's more cost. If there's more cost, that's bad. So how do you figure it out? Let's do some math. What do I have? A box. What shape is that box? A rectangular prism. Which is empty, yes? But we're going to fill it up with what? 3 golf balls. 1, 2, 3. Right? I need to find out how much empty space there is, yes? So is this a volume or a surface area question? Volume. What is it? It's the volume of what?
The box.
The box
Minus the volume.
minus the volume of the golf balls, yes?
And it says they fit snugly against all sides. So
What is the box? It's a rectangular prism, right? What are the golf balls? Spheres. How many of them are there? So I've got to subtract 3 spheres. Now, if I say go right now, a bunch of you maybe will write down a couple of things, and then you'll go straight to your calculator. Even though we just did that whole big thing about how you shouldn't go to your calculator yet. Here's why. What is the formula for volume of a prism? What's the formula for all prisms? We spent yesterday building this formula. I had the blocks out. You were all like, yeah, we got this.
For volume?
For volume.
Area of the base.
Area of the base times the height. So this bottom, which is 3 by 3, times the 9, right? So the prism is 3 times 3 times 9. Minus, what are the spheres? What's one sphere? What's the formula for the volume of it? Right? How many golf balls are there? So what math do I have to do to that formula? Multiply it by 3. Before I even go to my calculator, what do I get to do with 3 and 3? Pardon? Why? Because it cancels. 3 divided by 3 is 1. Now, my calculation is super easy, isn't it? This is a pain on your calculator. But 3 times 3 times 3 minus 4 pi r cubed is super easy. You don't even need to go to your calculator yet, do you? What's 3 times 3? Yeah, you do, Evan. It's 9. What's 9 times 9? 81. Now you're going to go to your calculator for 4 pi r cubed. You go to your calculator once for one thing. Everybody with me? There's nothing new today. It's just using the formulas that you already know how to use. Except you have to think about whether you are doing surface area or volume. Do you need to memorize the formulas? Nope. They're all on your sheet. Right? Where does the challenge in this part of math come in? This set step right here. This is where you guys make your errors. Because you all want to find one of the golf balls, which is a pain to find with your calculator, and then multiply that answer by 3. But if you take 2 seconds to write it out, you can make your life way simpler. Yes? Everybody with me? Picking up what it is that I am putting down? Lovely. It is 10:28, which gives you 30 minutes to do pages 35 to 38. Which seems like a lot of work, but there's only like 4 questions per page. And the questions are gigantic.
35 to 38.
And this will be gone over on Tuesday, because you're taking Monday off. I told you, you worked so hard this week, I'm giving you all 3 days off. Tuesday. Now, the more astute members of the class that are looking down the right-hand side of the screen will notice what is next. When will that quiz happen? Any time after you see how to do this. Right? Do you all know what I mean by sketch a net? No. No. Sketch the shape. What makes the pyramid? So let me give you an example. If I had this shape, an octagonal pyramid, what makes that? There's an octagon on the bottom and 8 triangles. That's what I mean by a net. Why you got to be that way? Everybody cool? Okay. Now, I made a fun joke with this in the other class, but nobody got it. You can't go fishing with a net, without a net. But what if a net doesn't like fishing? And then the other class was like, how can a net like fishing? It's just a net. Then I said, the name a net, and all 30 of them, a net's a name? Legit. You guys know a net's a name, right? So you get why that joke's funny. Can't go fishing without a net? Okay, go, do math. 4 growing